Hi, this is Ethan, a PhD student at the University of Toronto. Today I'm going to present our paper, Understanding Personal Data Checking and Sensemaking Practices for Self-Directed Learning in Non-Classroom and in Non-Computer-Based Contexts. In recent years, self-directed learning has become a trend among high school and college students. Self-directed learning emphasizes individual learning and enables learners to proactively engage in a variety of different learning strategies. However, being a productive self-directed learner can be difficult as individuals may suffer from being easily distracted or having poor motivation. Personal data checking has potential to address these challenges and facilitate behavior change. However, it is challenging to design such checkers for learning activities that occur in a non-computer-based context. Most learning checking systems adopt automated checking methods to collect and visualize course-based data on a computer, which fail to capture the behaviors that occur external to a digital device. To address the challenges with the data collection approaches that are adopted and the types of data that are collected by the current learning checking tools, we started Timing, a popular learning checking mobile app in China. In Timing, users manually check their learning data in various forms, such as videos, photos, and text paragraphs. Most of the users who employ Timing are senior high school students or college students. These users are preparing for competitive college entrance exams or the national entrance examination for postgraduates. Success on this exam requires students to take their own initiative to study. The above context makes Timing the ideal application to study how current checking practices support self-directed learning in non-classroom and non-computer-based learning contexts. The current study explored the following research questions. First, why are students motivated to use Timing to check learning data in non-classroom and non-computer-based contexts? Second, what kind of non-classroom and non-computer-based learning data do students check using Timing and how? Third, how do students make sense of non-classroom and non-computer-based learning data with Timing? We conducted interviews with 24 participants who were Timing users, recruited through direct contact or snowball sampling. Most participants were preparing for a highly competitive exam in China and used Timing to check their learning progress. We asked them about their usage of the Timing and the data they collect and how they make sense of the data and the challenges they face. The interviews were audio recorded and transcribed in Chinese. We use an open coding method to analyze the data. Our results are framed based on 3 research questions. To answer the research question, we found that there are 3 factors that motivate users to use Timing. The first factor is the motivation to persevere. The second factor is enhancing self-discipline, which is especially important for users preparing for college or graduate school entrance exams during COVID-19 lockdown period. The third factor is recording learning in various formats, which is engaging for users. Next, drawing on the analysis of the personal data that was checked by participants using Timing, we categorized the checked learning data according to the learning timeline. The first type of data is the learning schedule prior to undertaking learning tasks. Participants develop and capture learning schedule with detailed tasks allocated to the predetermined timeframes, documenting either physically or digitally. The second type of learning data is the learning process. Users check their learning process using video recording and timers. Video will sped up and include various learning activities, while the timers allow users to measure the duration of their learning task. Next, learning outcome. Participants record their learning outcome through photos, screenshots, or scanned copies. Thus include test papers, completed tasks, and the learning notes. Last, we found that participants also check their emotion during the learning activities. Moreover, We found that participants adopt a variety of strategies to make sense of their unchecked data and timing. First, replaying dynamic and temporal learning videos. Participants found value in replaying those learning videos as they provide detailed insights into their behavior, surroundings, and learning progress. Second, glancing through static visual data. Participants report that they often glance through static visual data such as learning schedules, completed exercise books, and emotion data as a way to reflect on their learning progress. They found that looking at photos of their learning plans and outcomes motivate them to continue learning. Third, migrating between different data while reflecting. Participants report that migrating between different data formats while reflecting on their learning. They did this to gain context and insights into their performance and to assure their preliminary assumptions about their learning performance. Lastly, participants manually record insights after reflecting on multiple data sources and timing to enhance interpretation. This method ease the burden of reviewing and help to clarify their insights. The study revealed how timing users proactively develop learning schedules, monitor learning states, and reflect on learning performance through self-checking. Mirroring the three phases of self-directed learning, these checking practices demonstrate that how self-checking using timing facilitates self-directed learning and metacognition. Participants checked both qualitative and quantitative data and found that they were complementary and allow for more holistic checking and reflection activities. The qualitative data was easier to interpret and contained direct intuitive contextual evidence, while the quantitative data provided a basic overview of the productivity. While prior work described teenager self-checking behaviors as intermittent and improvised, we found checking behaviors on timing to be continuous and persistent. The inherently high-stakes attributes of exams that most participants were prepared for may help explain these distinctions. Based on our finding, we provide design suggestions to support emotion data recording and record, balancing learning progress capture and privacy concerns, assisting interpretation of dynamic and temporal learning videos, and lowering the burden of comprehensive reflection with multiple data sources. For more details, please check out our paper. Thanks for your listening, and please check out our paper.